Okay, AP Calculus Limits Part 5. We did number 9 and we got plus infinity because the answer was 8 over 0 plus. Number 10 is the same, but as x approaches minus 6, that's why the answer will differ here. So it's 8 in the numerator. In the denominator, we have 6 minus square, so a bit less than 6. If we square it, we get 36. We get 36 minus, and a bit less than 36. Minus 4 times 6, 24, and minus 12. Minus 24 minus 12, it's minus 36. And 36 minus, a bit less than 36 minus 36 gives us 0 minus, so the answer will be k, positive number 8 over 0 minus, it is minus infinity. Now, since to the right of 6, not equal to the left of 6, one is plus infinity and one is minus infinity, the number 11, same number as x tends to 6, we can say directly does not exist. Now, number 12 is and 13 are very important. Its limit as x tends to 0 plus of x over, what is absolute value of x? What is absolute value of x equals to? Absolute value of x equals two things to be considered, right? Either x, if x is positive, if x is greater than 0, and minus x if x less than 0. Or we can say if x greater or equal 0 of one of them. We can put or equal with greater or with less than, because if x equals 0, absolute 0 is 0. Both cases are okay. So absolute value of x in this case, in the first case, number 12, as x approaches 0 plus, this means it's positive number. It's a bit more than 0, so the answer is x. And x over x, the answer is 1. The second one, its limit, when x approaches 0 minus, of x over absolute value of x. In this case, x approaches 0 minus, so it's minus infinity. It's a bit less than 0, so the answer will be, sorry, not minus infinity. 0 minus is a negative number, so it's a bit less than 0, so it takes this form, which is x less than 0, and that is minus x instead of absolute value of x, so it is minus 1. Number 14. Number 14, it's the same like numbers above. Its limit of 7 as x approaches 7. 7 plus 7 or 7 plus for this number is okay. 7 plus instead of x squared, so it will be 49, but a bit more than 49, minus 49, so it will be 7 divided by 0 plus, the answer is plus infinity. In case approaches minus, yani if we do the same limit as x approaches 7 minus, it for the same, for x over x squared minus 49, it will be equal to 7 over 49 minus a bit less than 49 minus 49. It's a negative number, so it's 7 over 0 minus, it will be minus infinity. I did that here because we need to find in number 15 the limit as x approaches 7. Since we have two different answers, to the right not equal to the left of 7, this means the limit also does not exist. Now, number 16. Number 16, it's limit. Its limit as x approaches 7 of x over x minus 7 squared. And this is important too, because it's 7 over 7 minus 7 to the power 2 is 0. But we consider it as 0 plus. Why? Because as x tends to 7 means either x tends to 7 minus or 7 plus from the right hand or from the left hand. So because we are squaring it, the answer inside, whether it is 0 plus or it is 0 minus, it gives me 0 plus as an answer because we are squaring this positive or negative number, so the answer will be plus infinity. Number 17, it's a piecewise function. It's f of x equal two polynomials, two different polynomials. It's x squared minus 5 as x less than or equal to 3, x plus 2 as x greater than or equal to 3. We have part A to find the limit of f of x as x approaches 3 minus. What's the meaning x approaches 3 minus? It's a bit less than 3, so we take the first case, right? Because x less than or equal to 3, it's x squared minus 5 instead of f of x. It will be 9 minus 5, which is equal to 4. Part B. Part B, it's the limit of f of x as x approaches 3 plus. And 3 plus means a bit more than 3. This means we take the other part, which is x plus 2 instead of f of x. 3 plus 2 equal to 5. What is limit of f of x as x tends to 3? It does not exist. Why? Because what do we have here is the left-handed 4 not equal to the right-handed at 3, which is 3 plus, which is 5, then the limit does not exist. Number 18, look at the difference between them. You can see, you can look and see they are the same function. They are the same function. So, what do we have here? What do we have? Also, piecewise function differs only in the second piece, in the second part of it, which is instead of x plus 2, we have x plus 1 in number 18. Then, the same. Part A, same thing exactly. Its limit of the function f of x, which is x squared minus 5. Why? Because x approaches 3 minus. So, it's the x less than 3, it will be 9 minus 5, which is 4. Part B. Part B, it's the limit of f of x as x approaches 3 plus. In this case, it's x plus 1 because 3 plus a bit more than 3, so x greater than 3. Then it is 3 plus 1, it is equal also to 4. Here, part C. Part C, here we go. The limit of f of x when x tends to 3. Since both left-hand side and right-hand side of 3 equal to the same, equal to 4, so the limit at x equal 3 and it is equal to 4. That's why they both are important. These two numbers gives us the difference between limit of f of x as x approaches 3 in both cases, in number 17 and in number 13. One of them does not exist and the other equal to 4 because hand side limit equal to the right hand side limit. Now find the limit of 3 cosine x as x tends to pi by 4. We can directly substitute instead of x its value, so it's a 3 cosine pi over 4 instead of x, and 3 radical 2 over 2 instead of cosine pi by 4. We all know that. Number 20. Number 20, its limit of 3 times x over cosine x as x tends to 0. What if we substituted instead of x its value? It's a 3 into 0 instead of x. Cosine 0 is 1. 0 divided by 1 is 0. So the final answer will be 0. This one in number 21 is very simple. We can take the limit outside. The constant number outside the limit. It will be in this form. And now, we said that before. Limit of x over sine x as x tends approaches 0 is 1. It's the reciprocal of limit of sine x over x. The reciprocal of 1 equal to 1. So 3 times 1 and the final answer will be equal to 3. This one here we can directly use the rule that says limit. The rule says limit as x approaches 0.